Welcome to Deep Dive Learning by HaleForm. This is Episode 4, S3D Piping Series, Part 2. In this deep dive, we're pushing on with our exploration of Intergraph Smart 3D piping. Today, we're focusing specifically on working with pipe runs and the objects within them. And our goal really is to break that down into the essentials, give you a clear picture of how to create and then, manipulate pipe runs in Smart 3D. Think of it like your guide to creating and tweaking piping systems.
Exactly. We'll unpack the key commands, the things you really need to watch out for when you're routing, when you're adjusting pipe runs. We want to give you practical knowledge, more than just clicking buttons. And as we go, it's worth remembering for anyone needing help with S3D piping modeling or administration, catalog customization, well, the team at HaleForm Technology Solutions, they have a ton of experience in this. They can really help streamline things.
Okay, sounds good. Let's kick things off with the basics. Yep. What exactly is a pipe run, and how does that relate to a pipeline?
Right. So fundamentally, a pipe run is a connected series of pipe features, straight pipes, elbows, tees, things like that. They all share the same nominal piping diameter, the NPD, the standard size, and they have the same flow direction. And the key thing is they're all governed by the same pipe specification. That's like the rule book for materials and components.
Right. So one continuous segment. Same size, same direction, same set of rules.
Precisely. And a pipeline. That's just a bigger thing made up of one or more of these pipe runs. A complex system might have loads of runs making up the whole pipeline.
And every single bit of pipe, every fitting in Smart 3D has to belong to a pipe run, right? It's the basic block.
Absolutely. That's the foundation. Now, when you actually want to create these runs, there are two main ways to go. You've got the root pipe command. That's kind of the main one for starting new runs. And then there's quick root, which, like the name suggests, is for, faster connections between existing bits.
Okay, let's start with root pipe then. Seems like the place to begin. If I'm starting a totally new run, what's step one?
First up, you select the route pipe command itself. Then you need a starting point. Could be an equipment nozzle, could be just a point floating in space if you're starting from nothing. Or maybe a tap on an existing line, a branch port, or even just a point along a straight piece you already have.
And once I pick that starting point, what then?
Okay, so if you're starting fresh, like from a nozzle or just in space, Smart 3D pops up the new pipe run dialog. Think of that as the setup screen for your new run.
Right, setting the characteristics. What do I need to put in there?
Well, you can give it a name if you want. If not, the system just generates one automatically. More importantly, though, you need to pick your piping specification. The rule set, remember. And the nominal diameter, the size.
The documentation mentioned a category option, too.
Yeah, that's where you define extra properties. Like if your spec uses service limits, you'll have to define at least one temperature and one pressure value there under category.
Okay, named it, got the spec, size, maybe temp and pressure. Now, how do I actually draw the path?
Right, so after you close that dialog, you start selecting points in the 3D model. That defines the route. And Smart 3D gives you some handy tools here. There's pinpoint for exact coordinates, if you know them. Point along helps you locate points relative to other things. And Smart Sketch 3D indicators, they're like smart magnets, helping you snap and align things. When you're done with a segment, just right-click to finish that bit of routing.
Sounds pretty helpful. What if I'm not starting fresh, but adding onto a run that's already there?
Oh, that's even easier. Select root pipe again. Then you can just click on an open-end feature of the existing run, like an unfinished pipe end or a flange. Smart 3D figures out you want to extend that run, or you can actually pick the run's name from a list that shows up in the root pipe interface.
Okay, couple of ways to hook into existing stuff. Now, the docs went into detail on specific methods within root pipe, like arc pipe runs for curves.
Yeah, for those non-standard bends, not your usual 90s or 45s, to do an arc, you select root pipe, then choose the arc routing option from one of the toolbars, usually. Pick your arc start point. Then, in the new pipe run dialog, same as before, name it, set properties. If the arc connects to an existing run, you select its name here too.
And defining the actual curve, radius and all that.
You'll need to put in the arc radius. Then you pick the center point, the arc pivots around, then the end point of the arc. And you can also specify the arc angle if you know it. Once that's all in, just hit finish, and there's your curved pipe.
What about flexible pipe? Sounds like that might be different.
It is, yeah. For flex pipe, you select the root flex pipe command, pick your start point. If it's an equipment nozzle, it might prompt for a new run or find the connected run if you've got P&ID data linked. Name it, set properties in the dialog, then just click the endpoint for the flex pipe. And again, if your spec has service limits, you'll need temp and pressure.
Okay, fairly straightforward for Flex. Now, the docs really dove deep into using coordinates and distances with Pinpoint for, like, super precise routing.
Oh yeah, pinpoint is powerful for accuracy. If you need to hit a specific coordinate, you go to the pinpoint command first, pick your coordinate system, use the rectangular coordinates option, then start route pipe, pick your start, set up the run properties. The key bit is using pinpoint's set target to origin and typing in the exact easting, northing elevation. Click in the view, bang, pipe goes right there.
Incredibly useful for tying into exact locations. What about routing, say, a specific distance away from something?
For that, you still use pinpoint, but choose relative tracking. Then you can pick rectangular or spherical coordinates. Rectangular is for x, y, z distances. Spherical is distance and angles. Start route pipe, set properties, then type the distances into the pinpoint ribbon, click, and the pipe goes that exact distance and the target moves, so you can keep going precisely.
And spherical is when you need distance and direction like a bearing.
Exactly. Spherical coordinates and relative tracking lets you input distance, azimuth, horizontal angle, and elevation, vertical angle. Very fine control.
The docs also mentioned routing with an offset. When's that useful? How's it work?
Offsetting is really handy for running pipes parallel to something else, like another pipe or a steel beam at a fixed distance. Start right pipe, set up the run, then select Set Offset Reference. Pick what you're offsetting from maybe the center line of another pipe. Type in the offset distance. Select the routing plane. Then, as you move near the reference object, you'll see a guideline. Click when it's right, and boom, parallel pipe at your offset.
These are all really strong techniques for accurate placement. Okay, we've covered creating new runs, some specific methods. What about just extending an existing run?
Yeah, super common and pretty simple. Just select route pipe like normal. Then click directly on the open end feature of the run you want to add to. Could be an open pipe end, flange, whatever. Smart 3D knows you want to continue from there. Then just route as usual, adding segments.
And extending an arc pipe. Slightly different because it's curved.
A little bit, yeah. You still start with route pipe, but you also need to hit the arc routing option again. Tells the software you're continuing a curve. Select the end feature of the existing arc. It'll ask for a new center point for the extension. You specify the new radius. Often you can just keep the same one. Then pick the new endpoint, and you can type in the angle for the arc extension if you need to.
Makes sense. Reestablish the arc parameters.
Ugh.
Okay, now, purchased length pipes. This sounds tied into the catalog data, right?
Oh, absolutely. To use this properly, your piping catalog and specification workbooks need the right data set up beforehand. Like in the pipe stock sheet, you need standard purchase lengths defined, min-max lengths, maybe flow direction info if ends are different. And in your specs piping commodity filter, you need pipe bends included. Plus, for the insert split function to work right, the weld short code in pipe takedown parts usually needs to be butt weld. Bit of setup involved.
Right. Assuming all that background work is done, how do I route using these standard lengths?
Okay, select route pipe, pick start point, define the run properties. The key is the route pipe settings dialog. Get to it via properties on the route pipe ribbon. In the defaults tab, find use purchase length. Set that to true. Now, the length of straight pipes you place is locked between the minimum and the standard purchase length. You typically route one straight segment, then another. The software automatically uses the purchase length and puts splits, weld gaps between them.
What if I set use purchase length to false? Do I lose all control?
No, not at all. If it's false, it won't automatically restrict lengths. You can still pick a preferred length from the straight option list, but you also get a length box where you can type in any specific length you need. Now, if the length you type in is longer than the standard purchase length, Smart 3D places purchase length pieces plus an extra bit for the remainder, again with splits. You can then delete that extra piece and it's split if you don't need it. Gives you flexibility.
Good balance between standards and specific needs. Can I mix different standard lengths in one run?
Yep, definitely. If use purchase length is true, place one length, then use the insert split command to end it. Then go back to straight option list, pick a different standard length, and keep routing. If use purchase length is false, you can type a length, insert a split, then pick a different length from the list for the next piece. Helps manage materials. And, managing materials, optimizing catalogs, that's exactly the kind of thing where HaleForm technology solutions can really help optimize your setup.
What about starting a purchase length pipe right off a nozzle or another component?
Very similar process. Select route pipe, click the nozzle or component connection point as your start, then go into repipe settings, set use purchase length how you want it, and route away just like starting from an open point.
Okay. Moving on, routing a branch at a specific angle to a header. Crucial for getting things right.
Absolutely critical for constructability. Select route pipe, pick the start point for your branch, the free end, click a point on the header pipe, roughly where you want it to go. Then this is important for accuracy. Filter your selection to piping features and click the actual header pipe itself. Finally, in the angle 1 box on the ribbon, type the exact angle you need for the branch connection. Smart 3D orients it precisely.
Very controlled. Nice. What about routing from R3D ports, those connections from reference models?
Yeah, working with reference models, you can route right off their connection ports. First, though, you got to make sure the attributes in the reference model are mapped correctly to your Smart 3D properties.
Okay.
It needs that link. To route, select Welt pipe, then click the R3D port. If you can't click the port directly, sometimes hovering over the end shows little graphics, glyphs like circle third, click one of those. In the new pipe run dialog, pick the parent pipeline, name your run, fill in any needed properties on the Reference 3D tab, then define the endpoint of your new pipe.
Is there ever a time I'd want to route near an R3D port but not connect immediately?
Yes, sometimes you need that flexibility. Maybe staging connections. If you want to start near an R3D port but not have Smart 3D automatically connect, hold down the S key while you click the R3D port after starting route pipe. Lets you define the run as usual, but it won't create that link right away. Works for new runs or extending existing ones near a reference model.
Gives you options. Okay, big topic now, crank clouds. Using laser scan data, how does routing work with that?
Hugely powerful, especially for brownfield projects or as-builts. You need the CloudWorks for Intergraph Smart 3D plugin installed and set up first. That involves connecting to your point cloud databases, referencing the data into your model, maybe applying filters to clean it up visually, getting this integration right, creating that accurate digital twin from scan data. That's definitely complex stuff where HaleForm's expertise really shines.
Okay, assume the cloud is loaded. What are the key things to remember when actually routing against it?
Well, the documentation suggests placing straight segments first is usually best, and pick points on the cloud in a logical sequence along the pipe path. Couple of limitations to know. You can't directly route arcs just by picking points on the cloud, and you can't use cardinal point offsets easily. You're usually referencing the apparent center line you see in the cloud.
So how do I actually select those points in the cloud to define the pipe?
You use route pipe, then hold down CTRL and shift together while you click a point on the cloud where you want the pipe to go. It shows a temporary graphic of the potential pipe. Make sure lock angle on the ribbon is off and plane is set to no plane. That's important for cloud routing. Oh, and Smart 3D might notice if the diameter you're routing doesn't match the cloud data. It might ask if you want to use the diameter it sees in the scan.
That diameter check sounds useful. What about branches? Can I connect branches using the cloud?
Yep. You can branch into or out of a header run you've routed against the cloud. To branch in, use CTRL plus Shift to pick a point on the cloud where the branch meets the header, and also select the header pipe itself. If it's aligned okay, Smart 3D should place the T or ULIT automatically if it's in your spec. Branching out is similar. Select a point on the header to start, define the branch run properties, then use CTRL plus Shift to pick points on the cloud for the branch path.
And inserting components, like valves or flanges, using the cloud as a guide.
Absolutely essential for as-builts. After selecting Insert Component and picking your part, use the reference position options on the ribbon. For flanges, things like back end of flange 1 are key. Lets you use the scanned flange faces in the cloud as precise placement references. You'll often use CTRL plus Shift again to pick a point on the cloud component for insertion and maybe rotation to get the orientation right. Really helps match reality.
Okay, last creation tool before we talk modifying. Quick route. How's that different from route pipe?
Quick route is all about speed for connecting existing stuff. Select Quick Route, click an open end, a nozzle, a straight pipe, or even a surface-mounted component to start from. Then click the second end or nozzle you want to connect to. Smart 3D figures out the possible paths between those 2 points and shows them dynamically. You just cycle through the options, pick the one you like, click Finish, and it builds the connection automatically. Great for joining runs, connecting from nozzles, making simple branch connections quickly.
Definitely sounds like a time saver for common connections.
Yeah.
Okay, we've covered a lot on creating runs. Let's switch gears to sloped piping. That adds complexity, right?
It does, yeah. Routing sloped pipe has its own challenges. The main way is to use route pipe while you're in an elevation view. In the new pipe run dialog, you specify the minimum slope needed and the slope direction high point down or low point up. There's usually an option on the ribbon to unlock the slope temporarily, maybe for a vertical drop within the run. And, like always, define temp and pressure if your spec needs it.
So you set the slope up front. What happens if it bends like elbows in a sloped line?
Good question. Smart 3D tries to maintain the slope. But sometimes, after routing or moving things, turns like elbows might end up slightly out of tolerance. There's a specific Modify Slope tool for this. You select the elbow, run the tool, and it usually gives you a list of slightly different slope values you can pick to bring the connected pipe back into tolerance.
The docs also mentioned adjusting a default change of direction rule in the catalog for sloped pipes.
Yes, that's important. For Smart 3D to automatically place the right fittings, like elbows on sloped runs, the catalog needs the right bend angles defined in that rule. You might need to check and adjust the bend angle from and bend angle to values in the catalog to cover the angles created by the slope. Then you have to bulk load the catalog changes into your project. After that, routing should place fittings better. It's also often smart to design with the slope slightly more than the absolute minimum, gives you some wiggle room later.
What if a pipe run needs multiple slope directions? Like slopes down, then levels out, then slopes again.
That can get tricky. In the Specify Slope Direction dialog, you'd choose the option for multiple slopes. Then you'd basically route in segments. Route the first slope part, right-click to end it. To continue with a different slope, start Route Pipe again, choose to continue the run, select the end feature, and then in the dialog, specify the new slope direction for the next segment. Repeat as needed. But the documentation does warn that runs with multiple slopes can sometimes act weirdly during modifications later, so use it only if you really have to.
One last thing on slopes. Removing small miter fittings. What are those?
Yeah. Those can sometimes pop up if you manually place a standard 90-degree elbow on a sloped line, then route directly off its end, instead of letting Smart 3D figure out the elbow angle itself. To get rid of them, select the miter fitting itself. Then in the Angle 1 box in its properties, usually on the ribbon, just type in 0, 0. Smart 3D removes the miter and adjusts the main elbow's angle to fit the slope properly. Helps if your catalog has trimmable elbows, usually.
Okay, creation and sloped piping covered. Now, modifying things already in the model. Moving, disconnecting, deleting the everyday changes.
Right. Design changes happen. You need to know how to modify efficiently. Let's start with changing flow direction in a run. Common need.
How do you reverse the flow?
Select the whole run first. Use the Select tool. Set your filter to piping runs. You'll usually see little flow arrow indicators on the run. Just click one of those arrows. Smart 3D pops up a flow dialog. You pick the new direction, bidirectional, upstream to downstream, downstream to upstream, no flow, undefined. Lots of options. You can probably also edit the flow direction in the run's main properties dialog, too.
What about merging two separate runs into one?
Okay, to merge. First, select an end feature of the run you want to basically get rid of, the one being absorbed. Then hold down Shift and select the end feature at the other end of that same run. This selects all the features in between. Now look on the ribbon for a run box or something similar. There should be an option like Select Graphically. Use that to click on the run you want all those selected features to become part of. Smart 3D moves the features over, but the original, now empty run still exists in the Workspace Explorer. You have to find it there and delete it manually. Oh, and if anything else was attached to that original run, like supports, move them first before deleting the empty run.
And copying a run. Just standard copy-paste.
Pretty much, yeah. Select the run using the Piping Runs filter. Use Edit Copy. Pick a from point anywhere. Then Edit Paste. Make sure Paste in Place is off. Then click a to point where you want the copy. Smart 3D might try to auto-connect if the end of the copied run lines up nicely, collinear, with another open end or nozzle. For copied branches, the branch end needs to be orthogonal, 90 degrees, to the header for auto-connect. Otherwise, you connect it manually after pasting.
We've hit flow, merging, copying. What about just editing properties of a run or its bits?
Easy enough. Select the whole run. Piping Runs filter. Go to Edit Properties. Opens a big dialog with all its attributes. To edit just a branch or a straight piece or an elbow, select that specific thing, Piping Features filter, then Edit Properties again. For individual parts, like a specific valve or flange, use the Piping Parts filter to select it, then access its properties. Often there's a quick Properties panel on the ribbon, too, once you select something.
Sometimes you need to break connections, right? Disconnect a run or just a few features.
Yep. There's a specific disconnect tool. Find it under Tools, Utilities, Disconnect. To disconnect a whole run, select it, Pipe Runs filter, run the command, breaks all its connections, deletes mating parts at the boundaries. You can also disconnect just a set of features. Select them, Piping Features filter, run disconnect. You can even try it on a single feature, though it might not work directly on branches or end features that way. The tool usually gives you a log of what it did, and you can often undo it if you mess up.
What about changing bend types? Can I swap an elbow for a smooth arc bend or vice versa?
Yeah, that's straightforward. Select the elbow, the turn feature, right-click it. In the menu, look for Convert Turn to Arc. Click that to go back. Right-click the arc bend itself. Choose Convert Arc to Turn. Gives you flexibility in how bends look.
Handy. Okay, back to those purchase length pipes. How do
Yeah.
we change their length after they're placed?
Couple of ways. If you have two purchase length straights next to each other, select both. See TRL plus Select Piping Features filter. Go into Properties. Changing the option value might merge them into one new length. Might need to delete the split manually, though. You can also split one long straight. Select it. Change its option value to a shorter length. Smart 3D usually creates a new piece of that shorter length, leaves the rest as a second piece. You might need to adjust the option of that remainder, too.
Moving things around. Fundamental stuff. How do I move different pipe objects?
Right. There's the main move command on the ribbon, good for bigger sections while trying to keep connections. There are also move from, move to commands sometimes on modify ribbons. You can select straights, turns, ends, branches, inline stuff like valves, even whole connected legs of pipe. Moving a straight usually slides it perpendicular to its axis. Moving an end feature changes the length of the attached straight, affects turns too. Moving a branch connection often lets you slide it along the header. If you try to move it off axis, the whole branch might move to keep the angle. Inline components usually slide along the pipe they're on.
And moving an entire pipe run as one unit. Similar process.
Yep. Select the whole run, Piping Runs filter. Use the standard move command. You'll probably need to pick a motion plane on the ribbon for the direction. Pick a move from point, then a move to point for the new location. If an open end of the moved run gets close enough to another open end after the move, Smart 3D often tries to auto-connect them, adjusting lengths.
The docs mentioned moving branches carefully to keep them on the header.
That's right. To slide a branch along its header, don't select the whole branch run. Select a straight pipe segment within the branch run. Then use the move command. As you move along the header's axis, the branch should follow. If you select the entire branch run and move it, it'll likely just disconnect from the header.
What about small welded things like socklets or weldolets? How do you move those?
For those, it's often best to select the oldet itself, the branch parent feature on the header, and the end feature of the branch altogether. Maybe use a fence selection, then use move, or maybe root multi-move. Pick a from point on the selection, to point on the new spot on the header. Should move them together.
And just making a pipe end longer or shorter?
Select just the end feature itself, Piping Features filter. Then you can often use Move To from the ribbon and click the new endpoint location. Or if you select the straight pipe segment, there might be a length box on the ribbon. Just type in the new length. If it's connected to an elbow, you might even be able to change the elbow's turn angle, which changes the straight's length too. And again, move an end close to another open end, it may auto-connect.
What about moving a whole chunk of pipe, but not the entire run?
Select one feature in the chunk you want. Right-click, use Get Features options like on same leg or connected to quickly grab the whole section. Once you have the set selected, use the standard Move command, pick from and 2 points. It tries to keep connections within your selection and might auto-connect open ends in the Move chunk to nearby stuff.
Can I use Move to actually make connections between things that aren't joined?
Yes, definitely. To connect inline, select an open end in your moving set as Move From. Select the target open end as Move To. Smart 3D should adjust lengths and join them. For a branch, select an open end in your set as From. Select a straight segment on the target header as To. Should insert a T or olet and connect. To connect whole legs, maybe select a straight on the moving leg. Use Move, pick From on it, pick To on the adjacent leg. It tries to figure out the connection.
Okay, last bit on moving. Boundary connections. Moving pipe connected to other runs or equipment sounds tricky.
It is a crucial point. When you move stuff connected at boundaries, Smart 3D tries to maintain connections, maybe stretching or shrinking pipes. But depending on the connection type, the approval status, working or not, your permissions, it can disconnect things. The docs detail scenarios for inline, flanged, non-collinear branch equipment connections, how it behaves if mating parts are involved, or if things are in different approval states or permission groups. Sometimes it just can't maintain the connection and breaks it, maybe creating a to-do record if parts are involved that you don't have permission to change. Understanding this is vital, especially in workshop projects, to avoid messing things up accidentally. Managing this complexity, again, something HaleForm's administrators are really good at.
Really highlights needing to know the status of connected things before moving near them. Okay, last major modification. Deleting stuff.
Right. Deleting needs care too. Smart 3D tries to clean up connections and related bits. Generally, you can only delete things in working status directly. Delete a whole pipeline, removes all its runs, features, parts, leaves gaps where connected, delete a single run. Same idea, removes its features and parts, leaves open ends, delete a straight pipe. Usually it leaves connected elbows or T's, might remove adjacent splits or run change features, delete an elbow, usually extends the straights to meet at the elbow center point, might remove mating parts, delete inline things like valves or reducers or splits, also remove mating parts like gaskets bolts. If the straights on either side are compatible, it might merge them back together.
And like moving, deleting at boundaries has rules and consequences.
Absolutely. Delete a run connected to another run or equipment. Smart 3D tries to delete the boundary connection features too if they're also working. But if mating parts, weld preps, flanges, are non-working or in a different satellite location, work share, it often creates a to-do record for someone with write access to fix. The docs give specific examples for welded, flanged, size change, T, outlet, equipment connections, how deletion works based on status and permissions. Deleting a branch or the header at a T-outlet has specific effects too. Knowing this helps keep the model clean and accurate when removing parts.
Wow. Okay, it sounds like both moving and deleting can have really significant, almost cascading effects. Understanding the behaviors, statuses, permissions, that's crucial for managing designs effectively.
Precisely. Modifying things correctly is just as vital as creating them in the first place.
Okay, let's try and wrap our heads around what this all means. This deep dive into creating and modifying pipe runs in Smart 3D. It gives you a solid base, right?
Yeah.
From the first routing commands, arcs, flex pipe, all that, through the precise coordinate stuff using point clouds, then navigating sloped pipe, and finally, the sometimes tricky business of moving and deleting things in a connected system. You should have a clearer picture now.
And this is where, it gets really interesting thinking about the expertise HaleForm Technology Solutions offers, like we've touched on. They have seriously skilled teams covering every aspect of Smart 3D piping, from the modeling techniques we talked about today,
Right.
all the way to complex customizations and the really critical admin side of managing the whole environment.
Exactly. So if you find you need help putting these techniques into practice, maybe setting up efficient routing, customizing things for purchased lengths or slopes, or tackling point cloud integration for as-builts, HaleForm's capabilities are pretty broad. There are S3D piping modelers, Smart 3D admins, the customization teams for catalogs, specs, rules. They can be a huge help.
And don't forget the programming side. They can build custom tools, scripts for hangers, supports, custom symbols, name rules, rule checkers, really tailor it. Plus, they have multidiscipline modelers too. It's a really comprehensive offering for Smart 3D piping. If you want to know more about how HaleForm can help optimize your workflows, just reach out to them. The email is business.development@haleform.com.
So, moving forward with your own projects,
Yeah.
we really hope this deep dive gave you some valuable insights and practical knowledge for handling pipe runs and objects. This was part 2 of our S3D piping series. And, well, judging by how much we covered today, there's clearly more ground to explore later on.
Definitely. And finally, just a thought to leave you with, something to mull over. We know digital twins and accurate as-builts are becoming more and more critical, right? For asset management, maintenance, future designs. So how might mastering these fundamental pipe run techniques in Smart 3D, especially modeling accurately against point clouds, how might that fundamentally change your organization's whole approach to the life cycle of your assets? Think about the long-term value of having that precise, easily modifiable digital version of your physical plan. What possibilities does that unlock?